All right, guys, let's go through number one. You can see up here my grid's got kind of... Okay, guys, we're not going to talk over you today. Do we see that my grid is a little weird? I don't know why that happened up here, but yours is normal, right? You have the normal. Okay. So the first line, -4, what is that? Just like a horizontal line, right? Okay, so down at -4, which is somewhere down here, I'm going to make that a filled-in dot, and then it goes that way. Are we okay with that piece?
Yes.
All right. Middle piece. I need to plug in the two endpoints. So when I plug in -2, what do I get? Okay. Now that's supposed to be an open circle, but that's already filled in by the other one, right? So it's going to be a filled in dot in the end. You can't really note that. And what do I get when I plug in 2?
0.
Okay, and that one's open. What do I do with those 2 dots then? Connect them. Okay. Third piece. The endpoint is when x is 2. So when I plug in a 2, what do I get? 0. And that one's filled in. Sure. What do I get when I plug in 3? Okay. And then you connect them. Arrow on the end because that one goes forever. How'd we do? Walking around, it looked like it went pretty well for most. So, we okay? All right. What we're doing today is piecewise functions that are not all linear. Okay.
So when it's an open circle and then there's another thing across it, does it come up?
It just like fills it in. Yeah. There's no way to really note like it was open and it's just closed. So, yeah. Okay, so let's look at number 2 together. What do you notice is different about number 2? Absolute value, parabola. We do not have just lines happening anymore. Okay, I will help, I promise. You start the same way with figuring out where the endpoint is. So I'm still going to plug in a -4 on this first one. 4, right? -4, 4. Open or closed? Open. -4, 4. Okay. Now, you can still plug in points less than -4, but you can't just connect them with a straight line because this is not a straight line. So let's think about what we did in 10.1, where we graphed with our transformations. This is a parabola shifted where?
Like, to the left.
Left 6, right? If I just said graph that, what would you tell me? Left 6, correct? Okay. Left 6 is in the window I'm talking about, right? X is less than -4, so I'm going to plot that point. That is your vertex. Well, if I had just said graph this, what would you do? Right? Wouldn't I just plot that point? And then I'd go 1, 1, 2, 4, like I'd graph it from there. Okay. That's what we're doing. So from my vertex, I know 1, 1.
But doesn't that stop on the right side?
Right. That's why we put our endpoint first, so we know where it's going. It's not bad. But this is why we do parent graphs first with transformations, because you have to be able to think about what is happening here. Where are we shifting? Okay. All right, middle piece. Let's find our endpoints first, because I've got 2 of them, right? So if I plug -4 in, what do I get? What do I get, guys? -3, good. Open or closed? Okay, -4, -3, closed. Other endpoint 0. What do I get when I put 0 in? -1. Is that one open or closed? Open. Okay. Should I do this? Should I just connect them?
That seems simple.
Seems too easy, doesn't it? Yeah. That is not the shape of this graph. What does an absolute value graph look like? A V. And then look at this. What transformations have happened to that graph? Yep. So do we agree that the vertex is over here at -1? Okay. And then it's upside down. So that's the only part of the absolute value graph that I get to graph.
Is it a 1?
-1, 0 would be your vertex. And then we know it's going down. The only part of it we're getting is between those endpoints we plotted first. So you plot those first so you know where to stop. Okay.
Also, when you look at that, you look at, to get the vertex, you look at like x6 or x1 or whatever's over there. And you can.
Yeah, because that's what you're graphing on, right? All right, guys, so the last one. It's written as 4 minus x squared. Do you guys understand that that's the same as -x squared plus 4? Okay. Endpoint, plug 0 in. What do we get? 4, okay. Filled in dot, right? Okay, think about this parabola right here. What transformations have happened to that parabola? Yep, flip over the x-axis and up 4. So the point I plotted, you guys see how that's your vertex?
Yeah.
Okay. Am I going to draw both sides of the parabola? No. Which side am I drawing? Right side. So I'm going to get this point and then just follow your parent graph pattern. Why did you say x plus 2 squared? I don't know where you're getting a 2. What are you looking at? Julian, we're on this one. Like, there's no 2.
Wouldn't it be like, x minus 2 squared, you get x squared minus
You get x squared minus 4x plus 1. Yeah. Nope.
How come we don't have y-axis if there's negative on x?
It's not a negative in here with the x. It's a negative outside. Okay? I know it's tricky. All right. Try number 3. Just number 3, guys. See if you can do it. It only has 2 parts. Try your 2 pieces here.
No.
Look at your neighbors. Do you guys agree? Are we arguing? Are we okay? Two Got it? What are you reading now? Oh, interesting. You always have some good looking books, so I'm like, what is she on now? Check when you're ready, guys. How'd we do? -6 doesn't really show up on my graph, so I just put it down there somewhere.
I did something similar, but the arrow went too far.
Okay, yeah, it's really tall and skinny when it's cubed. Yep. All right, guys, let's look. So -6, I think everybody's good with the horizontal line part at this point, right? We can do those. Okay, then it's a cubic function. So I plugged in the endpoint, so I know where that is. And then I visualize it. I go, okay, that's my cubic function shifted left 1. And I just grab the cubic function from there. Portion? It does on the right. Because it says only x value is greater than or equal to -2. So it's got to stop. That's why we plug in that point so we know where it stops. Questions on 3? Okay. Try 4. Don't be scared of the middle one. If you get stuck on it, make sure you get the other 2 pieces. Try number 4. Chris, ready? Number 4.
Yeah, so then
I mean, if there's no more things to do,
Yeah, look at your middle piece again. Think about what happens on that graph.
It would be
Oh, yeah.
I want to see like if I were to hold my and then I could do that. Or if I wanted to. So wait, I wish I just had no let's see, if we had a we know we want to do apples.
Oh, yeah.
And it's like this thing. And they only are just like that little. Okay, guys, looks like everyone did well with the first piece. Most of you did well with the third piece. And almost everybody got stuck on the middle piece. So let's go through them. X, we know that's a line. My endpoint here will be at -3, -3. Open. And then it went this way. Are we good with that piece? What'd you say?
Which piece?
Well, it says X is less than -3, so like you could plug in -4 if you want to go that way. Okay, the middle piece, the part you got stuck on. Let's look. Focus up here, guys. Krish, Tommaso, guys, up here. All right, 3 over X. What kind of asymptotes does this have? Horizontal and vertical, right? Can X be 0? No, so I know I have a vertical asymptote at 0. I have a horizontal asymptote at 0, but it will only go from -3 to 3. So I've got that. Okay. Plug in your endpoints. What do I get when I plug in -3? -1. Okay, that one's filled in. What about when I plug 3 in?
Oh, the asymptotes?
Oh, the last.
3, 1.
How do you know that?
You have to know your parent graph. 3 over X.
Oh. Okay.
Rational function, guys. Dividing by X is going to give you an asymptote. It cannot be 0.
How do you know the other points?
So you know the general shape. If you're unsure, plug in like 1 and -1 if you need another point.
Oh, so we don't need to do that?
You know it's going to follow this, right? Like I'm fine with you drawing that with the arrows on the end.
Like, what would be less than -1 instead of greater than?
What's 3 divided by -3?
Wait, okay.
Yeah.
No, I'm sure why you would replace the 3 with
It's the endpoint, right? We've been doing that all along, where you plug the endpoint in. That's all I'm doing, plugging in the endpoints. All right, third piece. If I plug in the endpoint, 3, what do I get? 2, filled in, right? Okay, guys, square root graph. What does a square root graph look like?
kind of like an S.
What's 3 minus 3? Square root of nothing. Plus 2. All right, so what shifts have happened to my square root function? Right, 3 up 2. Isn't that the point I just plotted?
Yep.
Yeah, so I know I can follow my square root function from there. 1, 1, 4, 2. I'm somewhere way off my grid. Okay. Questions? Anybody? We got it? Okay. Yeah.
For the 3 over x thing, can we ever just have one?
Yes, so let's say the window had been from like 0 to 3. Then I'd only have the right side. Yeah, a little wet out today. At least it's not hot out. We'd be melting in here.
What's the last place, right?
Let's see, 7, 4. Actually, 8, 4.
All right, thank you.
Sorry, I don't have things to count. All right, let's turn the page, guys. We're just going to go through a couple of these at the top. So this one is my g of x function, right? My whole graph did not appear, so definitely look at yours instead of mine. So what this is asking you to do is use these graphs and evaluate the function operation you've been given. So g minus f of 10, you just need to find g of 10 and subtract f of 10 from it.
Oh, I thought it was like.
Okay.
It's much easier than it looks like it's going to be. Yeah, so look at g of 10, go all the way out to 10. What is the y value? Not positive 3. Negative 3 minus, look at the f1 and go all the way out to 10. What is that? Minus 5. So what do we get as an answer? Okay. All right, try letter B. That's the last one we're doing in this part, okay? So you need to think about f of 6 times g of 6. Sarah? Well, in here, that's f times g, right? Okay, that's all. Whatever that operation is, that's the one you're going to do. All right, what's f of 6, guys? Times, what's g of 6? Okay, did we get negative 5? All right, easy?
No, give me a moment.
Oh. You go to the x value of 6. What is the y value? The top graph is f of x, the bottom graph is g of x. All right, guys, do number 5 for me. Nope. We are not.
We're on the same page. Ooh, I don't like that. Oh. What do you do with the negative?
Okay, so start with your endpoint, right? So I can plug -4 in. What do I get?
2.
Okay. -4, 2. Can I plug 2 in? No. Into, yeah, you get an imaginary, right? So what's like the last value in that window that would work? What do I get with 0?
Oh. I haven't got something. You got it.
So that is the middle piece, guys.
I didn't
Why is the second point 0, 0?
What's the square root of 0? Okay. Can I plug the 2 in? Like the other endpoint that's listed there. Okay, but why? Do you not see why?
Because plugging 2 will be
You get an imaginary number, right? Okay. So what is the last number in that interval that you could plug in? Between -4 and 2, what can you actually plug in? Right, that's the last thing, because anything to the right of that will not work.
Are we doing number 6?
We are going to. Guys, let me put 5 up here. I'll go through it. So you can check. Well, no, that's the blue piece.
Oh, it's just the coin.
My wrist? Well, I just got a little.
No. Is there a fraction with a 0 in the denominator? Okay, that's the only place asymptotes come from, or logs. Okay, can you plug in 2? That section of the graph is imaginary. It is not a thing you can plot. The graph stops at 0. Just like the parent graph, if I said graph square root of x, you would do that. This is saying square root of negative x. What does a negative in with the x do? No, what does a negative in with an x do as far as graphical transformations? Over. Yeah, so this graph is going this way. That's what you're graphing. There is nothing on the right side of it.
Do the day.
Yeah, literally. I was just like, you do realize
Are you kidding me?
negative, oh my god.
Guys, that third piece that I did in green, the cubic graph, remember, it looks like that shape. We are only graphing this piece of it, though. Okay.
I never done.
All right, guys, look at 5. What questions do you have on 5? Which piece are you talking about?
The first.
Yes. Like why we just get like a line?
Yeah.
Yeah, because if I graphed the whole thing, it would go all the way to here, right? Like that's the actual graph. But we only want that piece of it. Okay?
It's like, what's it called again? That little.
It's like that. Yeah.
You have to show that extra curve.
You can't without that part being in there. And that's not, yeah, I know. All right, guys, last one you are graphing, number 6. And then we just have 2 to write equations up. What's going to happen with the middle piece? What do you get out of that? A single dot. Yes. That gives you 1 point. Okay. So that one should be easy. That piece at least. You're not going to see like the kind of like this one.
I got the comment.
Graphing.
I sure said like 3 times and kept on destroying them.
So 1 minus 1 is 0.
Yeah, it's just going to be an open circle. Yeah. And they're both open.
Yeah.
This content really
My bad.
we were swimming. Wait, you're
Oh, but I think I put it.
yeah, I don't know what I want
Yes.
Maybe second. Oh yeah.
Right. All right, let me put them up here, guys. A lot of you got them. When I plug a 1 in here, I get 2, and that is an open circle. Guys, it's an absolute value, but am I going to see the vertex in the section I'm graphing? No, I am not. So I'm going to plug in 0, get 3, and I know it just keeps going that way. What do I get in the middle part when I plug 1 in? And that is filled in. Third piece, when I plug 1 in, what do I get? Okay, still open, so same open circle. And then guys, it's the square root function from there. So but it's stretched by 2. So if I go over 1, instead of up 1, I go up 2. Over 4, 1, 2, 3, 4. Instead of up 2, I go up 4. If I can count. So it's this stretched out version. You can certainly plug in points if you want to. Oh, I had already done here. Let me do it a different way, guys. Let's plug in 4. What do I get when I plug 4 in?
4.
Yeah, I think that's probably easier than trying to count for this. So 4, 4. There's your square root graph. Okay. How do we do, guys? Pretty good. Getting better at graphing piecewise. All right, last page, we're going to write equations. So let's do the first one together. The stuff at the bottom, we're not doing this max and min stuff yet. So cross that out. We do not need that. And the space up above is where you're going to write the equation. Okay, so this first graph, I have 2 pieces to it. Let's just do the x part of it. So if I look at that parabola, what x values would you tell me that's going to occur? Like, where is that going to happen? Less than or equal to 1? Yeah. Yep, and the second piece would be x is greater than 1. Yes. Okay. So guys, on an assessment, let's say you're looking at the graph and you're like, I don't know what the equation is. Show me you at least know that part, like that you understand the x values over which it's happening, okay? There's almost always partial credit to be found, okay? All right, so the first one, it's a parabola. Do you think we've got any sort of shifting, stretching, flipping? It is just x squared. All right, now the second one, we're back to just a line. Remember the form y equals mx plus b? So what does it look like the slope of that line is? 2, I agree. Now, this came up, a few people asked me, you know, do I need the y-intercept because I don't see it cross the y-axis? You still need it. You need to tell me the equation of that line, assuming you extended it all the way. So the y-intercept would be plus 1. So that is your final answer there. Okay. Do we see it? Okay. So guys, second one. I think the red piece is hard for you to see that it's even a section on your graph. Yeah, so realize that that's a little horizontal line there. Okay, so you're going to have 3 pieces on your second one. Second problem. So you guys try to write those 3. The red, look at mine. Do you see the red? Yeah. You see it in red on mine? Yeah, that's what I was saying. Look at it up there.
Is it inclusive of this one? Yeah. Like, is it
Well, it's included in something.
I mean, it's the red one.
Yeah.
Oh, yeah. I just assume there's a dark side. Yeah. If you wait, if you include it in this one, I can't include it. So that's good. Wait, it's not good. It's delicious.
So x is greater than or equal to 1, which means starting at 1 and going from left to right, it ends at 1.
Oh,
I don't think it stops at 1.
Can it be including no treatment? Oh, yeah.
Okay. Good.
So if you're any part of the graph less than -5.
So much more lot than I initially realized.
Keep track.
Wait. I mean, I think
Just staying on.
yeah.
There's a road going up. Oh, the hand sanitizer. I thought you said painting. Oh. Well, no, but then I said for painting, you said yes.
No, because I didn't hear you.
Oh. Yeah. Well, it cannot be. Probably have.
Oh. What?
I think I'm good.
That's what he said.
Oh, and the board. So it's this month. It expired this month, 5 days ago.
It'll tell us.
No.
Was the next class or
So wait.
What'd you say, sir?
How long?
Nope, we have one more lesson, and then, so that's Tuesday. Thursday of next week is your review day.
Oh, I'm not going
How long before our sanitizer expires?
For the assessment? Yeah, or if the next class you're in here, you take it. Where you want it in guided study, tell me, because I have to like take it down there. Is it a morning exam? They're usually done at like 12. Yeah, so yeah, I don't know that. Yeah.
7 years, got 21 years total.
Yeah, so just if you want to do it during like the next day during Warhawk time, just tell me so I have time to take it down there. Because if you come to Warhawk time, I'll be like, I can't go. Guys, when you're figuring out these X values, work your way from the left to the right so that you don't mess up your inequalities, okay? -5 is the smallest, and then the red piece, it looks like it stops at -2. I'm going to include that on this one. That just means I won't include it on the next one, right? I'll just go -2 is less than X. It's less than or equal to 1. You could certainly switch that. Don't include it on the red one, include it on the blue one. Okay, that's fine. This is an upside down parabola, shifted up 4. Last piece, I see a negative slope, right? It's going downhill. If I followed it over, it would cross the y-axis at 3, and that happens when x is bigger than 2. Okay? I'll leave that up there.
So I did good.
Oh, mine's cut off. I was thinking it had an arrow. So let's go to less than x, less than or equal to 5. Yeah. Okay.
So like I got it all right except I didn't put -x, so that would be wrong.
Because that would mean the line is going that way, and that's not what the line is doing. So you get that part wrong. All right, guys, I'm going to leave that up there. That's the end of our notes. I'm going to give you time to start on your delta math. Let me pull one over and show you something with. I just want to make sure you guys know how to click when there's multiple things. No, I want to start over. That's the one I want. Sorry, guys. Hold on. All right, guys. When you're graphing on delta math for these that are not linear, guys, look up here so to make sure you understand what we're doing. You pick which kind of graph it is. So if I want to do the parabola one first, I click on the parabola. Okay, it plots that for me. I do whatever sort of transformations are here. So I need to shift this one to the right 4. Okay. Then I click done. Once I do that, it allows me to figure this part out, the 1 to 7 part. So I bring this one all the way in until 1. I bring this one in until 7. Okay, click done. Then I can move on to the other line. Okay, it's at 5. Great, done. Bring this in because I want it less than 1. And I want that open. You guys see how you do that in steps? Okay. There's 5 of them. 5 graphs, that's all. Well, then that makes me concerned about your graph. Well, would you remember to draw it as open or closed on a piece of paper? Oh, okay. Yeah. Okay. Let me close this.